B, I think is where we're ready to talk about. I think I just drawn a little bit of a graph because I was trying to see if Emma was on the right track here. So, okay, reset the brains.
Yep.
Limit as x approaches negative infinity. And it's e to the negative x plus 1 minus 3. Now, depending what this graph is doing and what they're asking, that minus 3 and that plus 1 could be important. It's not going to affect the shape, but it could be important depending on where the, what the graph is doing. So, if we think about this, the normal graph does that, right? I'm going to erase this here in a moment. The normal graph does that. What's the minus 3 do? Drop it 3. What's the plus 1 do?
1 to the left.
Slightly 1 left. That's more, And then what does the negative on the x do?
Flip it.
Flips it across because it's a negative on the x, which are flipping across the y. So instead of I was going to be doing this, I'm going to be doing that. It kind of looks like it's going through 0, 0, but it's not. Okay, at least I doubt it is. So limit as x approaches negative infinity. As we go left, where's it going?
Positive infinity.
Positive infinity. Okay? Now, you want me to write notes? I don't really have anything. I think we're good there. I'm not going to write anything else if you don't mind.
That's totally
Okay. I guess, I don't know. Where to begin? Where to begin?
Well, that one's easy.
That one's easy. Okay. So we know the basic graph that would be here is going to be down 3. We've got an over 1 thing. But what's the other pieces? The important pieces here.
There's a negative on the base.
Negative on the base and
negative on the x.
negative on the x.
So it's reflecting horizontal and vertical.
Mhm.
Or x.
Oh.
Yeah. So
Which one do you do first?
Probably.
it's not going to matter.
Okay.
Now, and technically what we should be doing on all of these is we should be reflecting on all of these before we do the left, right, and up and down. But for what we're doing, it's not going to matter right now. Okay? So what do we, here's your normal graph, right?
Yeah.
Here's reflect across the y,
I'm gonna put it down.
and then reflect across the x.
Oh, where was
So I'm gonna add some.
Does that make sense?
Nice.
So it's going to look something like that. As x approaches positive infinity. Oh, it does matter this time. We have to know what that's approaching, yes? The fact that it moved down 3, right, puts that asymptote at negative 3.
So it's
So it is equal to negative 3.
Then how come I didn't do that on the A?
the white one.
Because we are approaching negative infinity, so we're going left.
Oh! It's your birthday, so I'll let it slide. But quit being mean. I can hear you.
Okay,
giggling at it.
D. Now, what's the 1/3 base tell us right offhand?
It's smaller than 1 but bigger than 0.
Okay, 1/3 base means my original graph starts like that, right?
No.
Double reflection.
Oh.
So we're going to go this way. We're going to go that way, right? And there officially was a
Plus 1.
+1. Honestly, it's not going to matter.
No.
I mean, officially, we're going to have to be, that's horrible looking, but this is a mess.
That's kind of making my head hurt. I'm not
I
gonna
know.
lie.
The +1 isn't going to really matter because as x approaches positive infinity, where are we going?
Negative.
Negative infinity.
You're a math teacher.
Do you think it would work if we draw multiple, like the steps?
And honestly, something like this would probably be a multiple choice question. So it's do whatever you want off to the side that, it's not going to matter. They're never going to see it. So
How many free response are there on the AP test?
I know. I was just gonna
6.
What's it like? So what are the sections?
Is there like
Comedy?
long and shorts? Like
Hold
there's
on.
science ones? Or?
Okay, real quick. You have 2 multiple choice sections and 2 free response sections.
Okay.
Now, you're putting me on the spot. I don't remember numbering. You have X amount of multiple choice
Mhm.
that are no calculator.
Okay. Oh, so it's
Okay.
like physics.
You have so many multiple choice, they're to no calculator. Then, and those end up being, is it two, basically you, maybe it's 30 multiple choice in 60 minutes. You get either 2 or 3 minutes of multiple choice question. I think you get 2 for those. So 30 multiple choice questions, 60 minutes, no calculator.
Mhm.
Then it's, I want to say 15 multiple choice questions with a calculator, and it's like 45 minutes. You get like 3 minutes a question.
Oh.
Then they give you 2 free response questions. Now, a free response question is an open-ended question, right? But there's usually like one free response question is usually part A, B, C, D.
Mhm.
So you get basically like 2 A, B, C, Ds, no, with a calculator. You get with a calculator first. So you get 2 free response questions, each about 4 parts. You get your calculator. Then you put the calculators away. Oh, and by the way, you get half an hour for those, I think. Basically 15 minutes per free response question. Then you put the calculators away. You can still have access to those 2 you just started if you want to go back and change anything. But you don't have your calculator now. And you get 4 more free response questions, and you get an hour now. But no, and so you have access to all 6, but now it's no calculator. So you can go back to those original 2, but you don't have the luxury of a calculator.
Okay.
That's the basic gist of it.
I kind of like how they do that.
So
That seems. I hated how they did physics. It was not it, and it just felt so like they gave us so much at once. So you're like, oh my god, which one do I do first?
yeah. Well, and you might feel like that when we, get to it, but
It was like 6 not multiple choice, free response, and you were like,
well, that's what it is here.
but like all together at once, like 5 parts each, and you're like,
That might seem the same here. I don't know, but okay, continue along.
what does the inside the parentheses mean?
Nothing really. It's just saying that it's the limit of this whole thing.
Oh.
Which, so I am showing there that we could have very easily had parentheses there. I'm not sure why there's parentheses on that one, and there haven't been on the first 4, because really there should have been on the first 4 if you ask me. Fair enough?
Yep.
Fair enough.
Okay.
Down 1, left 3.
Right, 3.
Oh, sorry. Right 3 with an increase.
Okay. Now, what's the question they're asking us, though?
As x approaches 2.
As x approaches 2. Does that change things a little bit?
A little bit.
Yeah, I mean, Hannah kind of talked about, okay, it's a graph. It's going to move down 1. It's going to move right 3. So, I don't know. It's going to do something like that. Does that really tell me where it crosses or where the x value is? Or what the y value is as x approaches 2? So what's another way to do a limit? Can we try plugging it in?
Yes.
Okay. And that is an option. So if we plug this in, this becomes e to the
Negative.
2 minus 3 minus 1, which is e to the negative 1 minus 1. Now, if this is a multiple choice question, you would not see the answer like this. What's one step they would at least do? No?
So it would be a reflection across the y-axis.
But that's not what we're saying.
No, I'm just saying here's our answer. We can't look at the graph on this one. This is our answer.
Oh.
So on the
But multiple choice, they're not going to show you the answer in this form. What's something they're going to get rid of here? They're going to probably get rid of that negative exponent. I can't guarantee that. They might leave it in there. But how do you get rid of a negative exponent?
1 over e. What Mario said.
Okay, so this is going to be 1 over e minus 1. That could be a multiple choice answer. Okay. However, they could go ahead and put it together as one fraction. What would my common denominator be if I'm going to put this together as one fraction? We have denominator of e here. No e here, so it would be a denominator of e. This is already a 1, yes. Minus, what is 1 as a fraction with a denominator of e? E over e, right? E over e would reduce to 1. So this is going to be 1 minus e. Okay. Now, why do I show you both forms? Sorry, I was getting that out of the way. It was one of the huge issues, one of the big huge things of AP is you get your answer. Half the problem could be which answer is it equivalent to. Okay, you have to be able to get something of equivalence. Okay, we good?
Yeah.
Okay, so the graph there was irrelevant. Always beware. Okay. What about as x approaches negative 3 of 1/2 to the negative x minus 1 plus 5?
Plug it in.
It's starting like this.
Yeah. I mean, yeah, you can move this graph and everything, but are we going to know anything about negative 3?
No.
Unless it happens to cross an axis there? Probably not. So let's plug it in and see what happens. 1/2 to the negative of negative 3. So positive 3 minus 1 plus 5. 1/2 to the second plus 5, yes? Without your calculator, give me a nice neat answer here.
21 fourths.
Okay, what?
Hold on.
Let's give it a second, guys.
Without the calculator.
Yes,
Oh,
21.
never before.
Yeah. Because
Process it for yourself for a moment, or as you're kind of mumbling here.
They watch it right there.
I know, but this is usually films class, so we get some interesting stuff.
I didn't do
I was confused you got the 20, but you just finished the problem.
Yeah, okay.
I decided if I just.
I'm not 1/4.
Are we good with this though?
Yes.
Now that I, you know, and that's. Can you guys follow that if I finish it out for you at this level? Yeah. I can just write that and let you guys look at it. You'll be like, oh yeah, okay, yeah, I can get there. You just had to process through it. Okay, so you know we did a lot with infinities here. They threw in a couple of tricky ones. You know, beware. Okay. Looking down the next part. You'll notice here, you know, if you remember this lesson was the transcendental functions. And notice it says most of the work you have done with this limits have dealt with polynomial or rational functions. When confronted with trig functions, you will find throughout the course that there are several methods to use. Let's begin with the basics, okay? So the basics being direct substitution, right? That's one of my first go-to methods is can I just plug stuff in? So if I start plugging stuff in, the limit as theta approaches pi over 3 of cosine of 2 theta over theta. So if I plug this in, plugging it in means the limit's going to be gone. So it's the cosine of 2 times pi over 3 divided by pi over 3. So let's see, this becomes, I don't know why I wrote that as a separate step, really. Cosine of 2 pi over 3 divided by pi over 3, yes?
Mm-hmm.
Okay. Cosine of 2 pi over 3.
Negative square root. No.
Square root
Negative
of
square root of 3 over 2.
3 over 2, yeah.
But negative.
Negative is what part of it,
Yeah.
I think.
So here's pi over 3, yes?
Mhm.
Where's 2 pi over 3?
Negative 1.
So I can definitely agree with we're going to be talking negative. I haven't gotten past that, okay? So negative of some fraction, right? What's cosine of pi over 3?
I need to memorize that chart again.
Or
Yeah, me too.
1.
I can write it out. I can't think of it on the spot.
Okay. Or could you go straight to a triangle here?
Mhm.
I don't know. Are you guys going for the chart or the triangles?
Chart. 'Cause
Okay.
Triangles honestly don't make sense to me.
No, same.
That's a good choice. Or,
I just need to remember what goes in each spot. That's my issue.
I need my unit circle.
There's my chart there, right? And the way we have the chart set up, okay, box 1,
1/2.
1/2. Diagonal box at the bottom
1/2.
is also 1/2. Box next to it,
No, square root.
square root of 3 over 2. Diagonal down below,
Square root of 3 over 2.
the middles,
1/2 of 1.
no,
Oh, 1 over square root of 2.
square root of 2 over 2.
Yeah.
Now here, honestly, we know tangent is sine divided by cosine. So even if you don't memorize it, it's easy to, because I'll be honest, I sometimes for a tangent of 30 and 60, I have to pause and think which one's which. You know, I know tangent is 1, because something
Yeah.
divided by itself. If I go down here and do this one first, sine divided by cosine is going to make this just be square root of 3, because the 2's cancel, square root of 3 divided by 1. Up here, sine over cosine is 1 over square root of 3, which is square root of 3 over 3.
Okay.
Now, and here's the deal. Before your next test, put in a little bit of work of however you want to do that. If you're a person you'd rather draw the triangles out, draw the triangles out. Like, I don't care what you do. Look up on YouTube. There's some kind of hand trick that I've never really learned.
What?
Teach yourself there's some kind of hand trick. Maybe similar to like the 9 trick.
Yeah.
You know.
I taught Cody that the other day.
So, the 9 trick is the trick
9
Kylie was
times 5.
using the other
1,
day.
2, 3, 4, 5. 45. 9 times 9. 5, 6, 81.
What are you doing?
9s are just so easy to remember.
3 times 9.
9's are easy to remember.
1, 2,
36.
I always have problems with 8.
So put your third finger down.
I had problems with 7.
7.
And like the high.
Okay. So, anyways,
Y'all are crazy.
what is the cosine of 2 pi over 3? Well, we need the cosine of pi over 3. 1/2 in quadrant 2 made it negative. And now I've got negative 1/2 divided by pi over 3, which is negative 1/2. Divided by pi over 3 is multiplying by 3 over pi, negative 3 over 2 pi, and you would leave your answer like that.
Is the triangle 60, 30, 90? Or is it 30, 60, 90? What?
Okay, so
I messed that up on
which
the
way do you
first
draw the
one.
triangle? Where do you put your right angle?
At the bottom.
Bottom left?
Bottom left.
Okay. So when you do this, what sides do you know?
I know 90, and then I get messed up between the 30 and the 60.
Well, so here, are you drawing it longer on the bottom?
Yeah.
If I'm drawing it longer on the bottom, this is a smaller angle, so it's 30.
Mhm.
This is a bigger angle, so it's 60. My shortest side, which is opposite the shorter angle, is 1. Hypotenuse is 2.
And then square.
The longer side, which is opposite the 60-degree or longer angle, is square root of 3.
Okay. Because I switched 60 and 30 on the test, and it messed me up.
It does.
Mhm.
Which is where you have to know it, right?
Mhm.
It's a work in progress. Okay, B. The limit as theta approaches pi over 2 of 3 times sine squared. Okay, let's do this. 3 times the sine of pi over 2 squared. Sine of pi over 2.
Be 1.
Yeah.
Yep.
1.
Because in an ordered pair, it is
What do you mean?
cosine
Oh, I'm so stupid.
sine.
So,
Yeah.
1 minute. So it's 1, 0 over here, 0, 1 up here, negative 1, 0, and 0, negative 1.
Yes.
Okay.
I need my go down my unit circle.
Okay.
Start staring at it.
And this is, review within, right? Like, and this is just think as you move from the center.
Yep.
You go right 1, up or down 0. You know, up
Yeah.
0, or left to right 0, up 1. So, okay. So 3 times 1 squared, which means 3.
I don't know where.
I looked at the wrong answer on my key, and I'm like, oh my gosh, how did we mess that up so bad? I looked up at 21/4. I'm like, whoa!
Oh, you made it.
How did I lead you astray so incredibly wrong? Whew. Not saying it can't happen, but that would have been bad. Okay, just like some polynomial functions, where a function value is not defined yet, a limit will exist. The same will occur with trig functions. Evaluate this limit by direct substitution. Okay, so let's do it. Sine of pi over 2 minus 1 over cosine of pi over 2 quantity squared. Right?
There's a problem.
Sine of pi over 2 is 1. So 1 minus 1 on top is going to be 0. Cosine of pi over 2?
0.
0 squared is 0. So what have I been calling this? This is an
And
what?
determinate form.
Oh, I have no idea.
Okay. This is an indeterminate form.
I started.
This is not an answer. 0 over 0 is not an answer. This is okay, let's find plan B is what this is. There's multiple different options for what plan B could be, but this is find a different option to get to your answer. Okay? We're going to talk about some of those options. Ooh, okay.
I know. That's what I was just looking at.
We keep talking. That's our problem.
And we didn't
Sorry,
even get
no,
all
I just feel like
today.
there's so much in this.
Okay. Few thoughts to consider. So notice this is the question from the previous page, right? Yes. Yeah, this is the equation from the previous piece. If you algebraically determine the function is undefined at a value, does that mean the limit does not exist? Can you look at the graph? How do you analyze the limit when no calculator or graph is permitted? And that's, the situation of how do you do this when you don't have the calculator to just graph it? If you can graph it, you can figure it out, can't you? Okay, there's, we can trace the graph, we can figure these things out. So, we need to use some trig identities and rewrite the function, and we're going to try that here. So, trig identities. Right now, this is sine x minus 1 over cosine squared x. We had a trig identity that we used a ton last year from that purple paper.
The
Sine squared
The
plus
theorem
cosine squared
thing.
equals 1.
yeah, that thing.
Pythagorean identity. Okay. We had our Pythagorean identities, I think is what we called them. And one of them was that sine squared plus cosine squared equals 1. So, if on top we have sine x minus 1, because I can't do anything with x, it's not squared or anything. What is cosine squared? How can I rewrite that?
Sine squared x minus
1 minus.
1 minus.
No, it's not.
Definitely not. Okay. Those Pythagorean identities still need to be available. This one will be used a ton. Okay, but that's the Pythagorean identity we all know easily, right? Oh, yes, you do.
Totally.
Okay. Now, with that in mind, let's factor that denominator. How do we factor this denominator?
1 minus sine, 1 minus sine. Or
That's
1 minus
one.
sine x, 1 minus sine.
No.
1 minus
1
sine
minus
x,
9
1
x 1 plus sine.
God, Doug.
Get it right, dude.
It's been a long week.
Well, considering I didn't even know where to start, I think you're doing okay.
This is where I want to say, be nice, everybody. Be nice to each other. But on the flip side, some of this is all in good fun. Let's make sure we keep it all in good fun, children. Okay.
You definitely said that to Natalie.
Okay. Oh, I say it to all my students, too. Okay. Are you guys good with this factoring?
I think so, yeah.
I was from Dublin.
It was difference of squares. Sorry. I'm watching Mario, and that was my mistake.
do?
And now I just drew attention to him, so he's going to get caught.
Did your goat fall out of your mouth?
He did that. The Pokemon picked it up and ate it.
All right.
He also.
Okay. Trying to focus. I'm trying. Sorry, that
We
one
can
I
do
couldn't
it.
focus
We
through.
can do it.
Now, what can happen here?
You can
The
cancel.
1 minus sign.
Okay, 1 minus sine x.
Actually, no.
It kind of does.
Because you get a
Mario.
negative.
Oh wait, you have a negative and it's like a factor out thingy.
Yeah.
Yeah.
1 minus sine x, the signs are exactly opposite, yes? So I can cancel them, and one place or the other, we're going to have a
Negative.
negative 1 remaining. Okay? So now I'm at negative 1 over 1 plus sine x, yes?
Yes.
I've taken some fancy math and I redid that. Let's retry this limit from the front side. The limit as x approaches, what was it? Pi over 2? And now it's going to be of negative 1 over 1 plus sine x. Well, I'm not going to get a 0 on top. It's negative 1 on top. Over 1 plus sine of pi over 2.
Negative.
Okay. So, go to show a little good old manipulation. You can still work with it. Okay, that was still plugging in. Okay, moving on. We've got to keep going. Okay. You got this. Your new skills to evaluate each limit below by first rewriting the function and using identities. Okay, so this is at chapter 5 last year that you guys loved in pre-calc.
No.
I did though.
Okay.
Congratulations.
The limit as theta approaches pi over 2. It's giving us the hint, so I'm not even going to try and plug things in right now. We're just going to clean it up, okay? What do we know here?
Cotangent equals. Oh,
Cosine
no.
over sine.
No. Does it?
What Mario said.
Oh, no,
Okay.
it doesn't have to be
Because-
squared.
Of tangent.
Yeah.
It doesn't have to be
Because
squared.
tangent, here's what my brain says, tangent is sine over cosine. So cotangent is,
Sine over.
Cosine over sine.
Cosine over sine.
so now we've got 2 cosine theta times cosine theta over sine theta. And here's the deal. We actually probably could have plugged in at cotangent, just not, well,
It just looks messy.
we wouldn't have been able to easily figure it out, I don't think.
Oh dang it.
Well, we could have,
Well,
I guess, but regardless.
I think we'll put a 0 though, isn't that?
We're not going to be divided by 0.
Multiply by it.
Because cosine of
Oh,
pi over 2 is 0.
I see what you're saying. So you're saying that I don't really need to combine this. You see that. Yeah,
Yeah.
valid point.
Even trying to put it in the beginning.
We could have
wouldn't
just put it
worked.
in the beginning, couldn't we?
No, it wouldn't
Well,
have worked.
okay. No, here's the catch. Wait. Cotangent. Give me a moment. Tangent starts with a 0. Cotangent.
So still I'll be 0.
It'd still be 0, wouldn't it? Well, I don't know. I just read the directions and assumed we needed to manipulate. But you're right. This one would have actually worked out. However, the thing is, if that cotangent would be an infinity and you had 0 times infinity, that's a problem. Okay, that's a problem that has to actually be looked at differently. Okay? So, at this point, when we plug in the pi over 2, it's 2 times cosine of pi over 2. And we're squaring that, whoops, over sine of pi over 2. We end up with what? 2 times 0 squared divided by 1. Right?
What? I thought we were trying to not get 0.
No, we're trying not to get 0 over 0 or a number. No, it's a number divided by
Let's-
0.
And we're trying not to get a number divided by 0.
No,
We're just not getting 0 over 0.
because a number divided by 0 is.
Okay?
Oh.
Now, in this case, as we noticed, yes, we could have plugged this in.
Yeah, that's what I was saying.
But, actually, wait a minute. What's cosine of pi over 2?
0.
And what's cotangent of pi over 2?
I don't know how to do that.
A 0.
I think we would have gotten 0 times 0.
Yeah, which then would just.
That is a problem, though. That's not necessarily, that's an indeterminate form.
Really?
Okay? If I'm not mistaken, either that or she just threw this one in and it's confusing me. One of the two.
Probably.
Both.
I don't know. Regardless, did we get it to a form that proves it's 0?
Yeah.
This proves it's 0, and that's the whole point of this, okay? Next one.
Sine over cosine over tangent. Under tangent.
Is it?
Never mind. Tangent is sine over cosine.
And that's what I would go with is tangent is sine over cosine.
And then you'll be able to.
And I
Never
think
mind.
this one you could work as is as well. This one you could work as is, I think. It's just going to clean it up a little bit, is the point here.
You can cancel out signs.
Yeah, because you'll be able to do some canceling. So the limit as theta approaches pi over 4 of sine of theta cosine of theta divided by sine over cosine, right? How do you divide by that sine over cosine?
Switch it around.
Multiply by the reciprocal. So we've got sine theta times cosine theta times cosine over sine, which is exactly where someone mentioned earlier the signs will cancel, and we just have
Cosine squared.
cosine squared theta.
I was gonna even go further.
What is the cos?
Here, I was trying to go further.
Well, we're going to go farther and we're going to plug it in. We have to finish limit. So now we're doing cosine of pi over 4 quantity squared. What's the cosine of pi over 4?
Square root of 2 over 2.
From our chart we just did on the other page, square root of 2 over 2.
That's 1/2.
That was a lot from that one answer.
Well, and here's the deal. Could you cut some of those steps out in your own brain? Yes. I wrote them out, just don't want to lose anybody. I want everybody with me, right?
Do you have,
What I meant going further was
What'd you
over
say?
here, when
No.
we were over here. I tried to change it to like 1 minus cosine. Or 1 minus sine squared.
Oh.
I know, I was going so far. And I
You
was like,
could. It would
why am I
work,
going
but
so far?
it's, yeah, it's
do
unnecessary.
you have the purple paper with all the,
I do.
can I take
Yes. Remind me at the end of class. I can probably pull some out you guys can actually just have.
I saw.
mine's in my locker, remember any of these?
Well, it's not doing any good thing.
Okay, so what do we know here? Speaking of not remembering these, what do you know about cosecant?
It is.
The opposite
of sine.
It is the opposite of sine.
It is the reciprocal of sine, so it is 1 over
So
sine.
they can, but then that doesn't that
At least
mess
one.
it up? So then there's 0 on the top.
That's just one.
That's not a 0.
It's a one, Sophie, duh.
Oh yeah.
Cancel, cancel. 1 over 3 theta, and this just became the easiest problem we've done all day. Right?
Whoa.
I'm
Yours
guessing
went really, really fast.
I did.
because we're running out of time.
We're not gonna make it, and that's a problem. Okay, so have you discovered a pattern in all of this yet? If you always try direct substitution first, 3 things will occur. 1, it might just work and you might get a number value. Fair enough? Okay. You could get a number value divided by 0. Okay. In that case, you can try factoring, you can try canceling, you can try rationalizing where we multiply by the conjugate, you can try analyzing the graph. Okay. So those are some options I have there that we can factor, cancel. I know my last one was analyze. Factor, cancel. Oh, rationalize is the one I forgot. The other option our fun 0 over 0 piece, right? And that is our indeterminate form. And with an indeterminate form, you have to go farther again, okay? Whether it be something like factoring, cancelizing, rationalizing, analyzing, you can look at a graph. Really, I almost feel like any of these would also work here. Okay? So, okay, next page.
Hey.
When you get to the next page, there's a nice big bold box there, guys.
Yep.
And it specifically says special trig limits, okay? Later in this course, you'll learn a smooth technique known as L'Hopital's. L'Hopital's makes some of these so much easier. It's crazy to believe. Okay? Now, it'll be a quicker method for evaluating many functions. For now, you might like to memorize these special rules as well. So, these right here. One of these popped up a little bit on the last review because we mentioned it previously. But the limit as theta approaches 0 of sine theta over theta is equal to 1. This one, I don't see this one as much, but it's always suggested that you memorize this other one, that this is as theta approaches 0 as well. 1 minus cosine theta over theta, but it equals 0. So my suggestion, become very familiar with these and tell your math teacher to learn how to spell. MEM.
O-R-I-Z-E.
Don't worry.
Excuse my frustration here. Yes.
Is that only if it's approaching 0?
Yes. It has to be that exact piece. It has to be approaching 0 for this to be true. If it's not approaching 0, forget it. And the thing is, when it's approaching 0, that's a special case. Because really, if we put in 0, this is 0 over 0.
Okay.
Okay? So these are values that are going to be 0 over 0 if you just plug in. And so this is a shortcut that you can just say, I know it's going to be this. Okay. Now, it says use a graphing calculator and the table feature to evaluate the following trig limits. The table feature, gosh, we went through that in pre-calc last year. How much do I want to go through it today? I mean, for something like this, you can pretty much just fill in the values, right? Like they already have it set up. It would be pretty easy to fill in the values. So can I write them down for right now? I probably should go through the table with you here in a moment. So 1.998, 1.999, D&E, 1.999, 1.998. Based on the table, the limit as theta approaches 0 of sine of 2 theta over theta.
There's a zero.
That's
There's an
the
asymptote or something at 0.
Okay? There's an asymptote or something, but it doesn't matter that it doesn't exist at the point. The limit is as we approach. So as we approach that point, what do we notice about both sides?
So coming very close to 2.
Okay, so this is equal to 2.
That makes sense. 'Cause
Okay, now, are we connecting here?
I think so.
This is very similar to this memory one up here, except what? There's a 2. Guess what? Sine theta over theta is 1. If you have a coefficient in there, it just multiplies it. Okay? That's what we're trying to teach you here. So, let's look at this next one. Let's see, negative 0.1, 0.446, 0.044, D&E, negative 0.044, negative 0.446. Why is that not what I've written down then?
What? What just happened?
That's not what I've written down, and I'm trying to figure out why. Ah. there's a catch here, and my brain is not remembering what. I'm guessing, okay. And on a time crunch, I'm struggling with my brain stressing even more. I have written down D and E on this one.
Oh, because they're same values. They're
It's a
not-
positive and negative, right? So it's a positive and negative. The key is, are they close enough that they're going to get us to 0 or not? And the argument is that they're not quite, because it almost looks like coming from the y value above and a y value below that you might make it. But this one does not. Now, notice, is this the same thing as this up here?
No.
No, it's not. Okay, so don't try, I know we want to make it look like that, but we're looking at the table here. Now, okay, you can take a guess at the next one as I fill in the values, but I'm going to tell you 0.738, 0.749, you can guess the 0, D and E, 0.749, 0.738. Excuse me. What is that leading us to believe?
3/4.
Right. 0.750 is what it's leading us to believe, which is 3/4. Again, does that make sense with your memorization one?
Yes.
Okay, so, and that's real, as I said, that's the one we see the most, right? That's the one we see the most.
No,
That's 0.
Okay.
Yeah.
Now, negative 0.223. Negative 0.022. D and E, positive 0.022, and 0.223. This one does lead to be 0, okay? And the reason this one does go to 0 is the order fits, because, those 3 and 2 aren't going to actually end up mattering.
So then how are we supposed to know the difference between D and B? Because if you look, they're following the same pattern.
But-
Oh, I'm so stupid. Leave me alone.
Remember what we talked about earlier that you already forgot, right? Are we okay, though?
Fine.
It's 1 minus cosine as opposed to cosine minus 1.
I don't think so. That takes some.
I hear a little anger there. That's all right. It's okay. We're allowed to get mad, frustrated, whatever. Happens to all of us. Okay, some algebra tricks with properties. You can take a guess by looking at this, and your guess is probably going to be right. Now, if we do a little math, that's not the math I was going to do. What are you guessing the answer is going to be?
11 halves.
11. Where'd you get 11?
8 halves.
8 halves.
I don't know, 15 halves.
Yeah.
15 halves is what I'm looking for.
15 halves was my first guess. And
I
I'm
saw
like,
the 8. Where'd the 11 come from?
Yeah, where?
What I did was I did the 5 halves and then multiplied the 3 times the 5 halves.
Are you crazy?
You still would have gotten 11.
I added 3 to 5 halves.
Oh,
So then I
okay.
did 3 times
Oh.
2.
So it was more similar to the 8 halves answer. Okay. I was just like, what did you do? Okay. So now,
Yeah, most likely I found that over too.
Yeah.
okay, 15 halves. Now, officially, if we want to show this, officially, if I want to show this, what we would have to do for this to truly work is to take this and multiply by the 5 theta to make, or the 5 over 5 to make this work. And I'll explain here. I meant to change colors there and I didn't. But with the idea, limit as theta approaches 0. I'm going to change colors so we don't. This 3 and this 5, I'm going to pull out front and say 15 times sine of 5 theta, yes? Now, what I'm going to do here is I'm going to pull the 2 out front, okay? And then this 5 here, I'm going to put with the theta and say 5 theta. Because those 5s match, That's how I can officially say that that is a 1, and then this piece is the 15 halves. Now, did you have to go through all that work to actually get that? No. I'm just trying, that's the official. Okay, this one is a little confusing, but this can be broken into 2 fractions. Do you see it?
It's just one.
It's just
No, because you can break it into fractions.
Kylie.
Oh, it's 3.
I could go with 3.
Yeah.
I'm going to break this into the fraction that is 1 minus cosine theta
Theta.
over theta. Why did I put a 3 there? You guys talking to me about 3
Yes.
Yeah.
messed me up.
Because the answer's 3.
Plus,
I know the answer's 3 now. I just got excited.
limit as theta approaches 0 of sine of 3 theta over theta. That whole break it into 2 pieces, do you see it?
Mm-hmm.
I'm just going to shortcut here and say, well, we know this one, according to our memorization from up top,
0 plus.
is 0. Plus this one, we see that 3 on top, so it ends up being 3 times 1. So we do end up with 3. Okay. Officially, I could show a little bit more. Now, do we have time for the rest of this?
We
Not
have 2
really.
minutes.
But here's the deal. That's stupid. Squeeze theorem again. We keep running out of time to squeeze theorem in. Sorry, I had to. Okay. Now, here's one. Okay. Squeeze theorem. Okay. Evaluate using a squeeze theorem. We have what looks like a parabola up top and a parabola down low. We have this funny looking equation in the middle.
Mhm.
As x approaches 0, what do we know? As we approach 0, what's that graph have to be approaching?
0.
0. Okay. Now it talks about explain why you cannot use the product limit law. And the product limit would be saying breaking this into 2 limits. Breaking this into the limit as x approaches 0 of x squared times the limit as x approaches 0 of sine of 1 over x. And the reasoning would be is that this one, you would get a DNE,
Oh, okay.
and that would cause us a problem. Whereas we can tell just by looking, everybody's going to meet at 0, 0, right?
Mhm.
Yeah.
So that's why, because that one does not exist. Okay. Consider the range of the sine function. Okay, remember sine, it goes up, down, up, down, up, down, goes between 1 and negative 1, right? So we can conclude that sine of 1 over x goes from negative 1 to 1. Multiply through by x squared to use the squeeze theorem. And that would just end up showing that the outside limits are the same, and so the inside limit would be the same. There's a proof there. We're kind of out of time anyways, and that's what both of these are. So we'll see. I might pick something to go through tomorrow like that, depending on what's in homework, which I don't remember off the top of my head.
The last 2 are squeezed there.
But see, last time I said that and I was wrong, so, okay. But it does say it this time, doesn't it?
Yeah.
Okay, so here's why. Do the homework, right?
Yeah.
You see where I'm going with that. Do the homework, attempt everything. What I'm probably going to have to do, you've got to hit squeeze there. So I'm going to have to talk about those a little bit. I don't have the answer key up yet. Hopefully I remember to do that before the end of the day. Otherwise, someone email me when you find it not up.
All right.
Okay? Huh?
The purple.
Purple paper, yes.